I lost the argument.
My name is Peter Warren, and I'm a PhD student here. And this is my topic actually, for my PhD. And we're really honoured today to have Gill Owen to present the topic on demand reduction and demand response policy, and looking at experiences from Australia and the UK. Just to give a bit of background to Gill, it's a very long CV, a very impressive one, just to pull out a few things. So Gill is currently a Senior Research Associate here, which is based in the Australia campus of UCL, the School of Energy Resources there. She was a Senior Research Fellow at Warwick Business School before then. She's worked a lot in the government, for example, was Vice Chair of the Government's Fuel Poverty Advisory Group, and a member of DECC Smart Meters Consumer Advisory Group. And she's been a non-executive board member of Ofgem too, as well as Ofwat. And also co-runs the Sustainable Energy Regulation Network. So thank you for being here today to give us this talk. Just a few general seminar structure things. There's a fire exit at the back there on the right, and also the way you came in on the left. The session will take the format of about 40 minutes speaking and 20 minutes questions. If you could hold your questions to the end, that would be great, unless it's a point of clarification. Also, after 7 p.m, the doors are locked, so you need to find someone who is at UCL, has a pass to get out. But we'll have refreshments upstairs afterwards on the first floor. The event's being filmed, and this will be online afterwards. And I think that's everything I need to say. So over to you, Jill. Thank you.
All right, thanks very much. Okay, well, nice to see so many people here. I'm going to talk, as you said, about demand response and demand reduction. A lot of the stuff I'm going to talk about, particularly the UK stuff, is based on some work that I've been doing over the last few years here with Sustainability First. And this is a 3-year project on electricity demand and the role of demand reduction and demand response in the electricity system. This is sponsored by a number of the networks and retailers, Ofgem and a number of others who are listed there. And we've organised it, organising it around a round table, smart demand forum with some of the consumer organisations and DECC as well. That has published a whole series of papers which are on the Sustainability First website. Anybody who wants to read a lot more about this subject, I recommend you go and have a look on there. So that's continuing through till next year. Obviously, I'm not as involved in it now as I was, but I am still involved in it to some extent. So that's a bit my way of the background of where a lot of the work has come from. The Australia stuff obviously is stuff that I've been doing since I've moved there last year. I'm just going to say a little bit about electricity demand in the household sector and set that in a bit of context. And then I'm going to talk then about the issue in Australia, peak demand. And some of the things I think that potentially suggests for the UK for the future in terms of how we manage not just overall demand, but also how we manage peak demand. So I'm very much focused on the household sector in this presentation, although the Sustainability First work that I mentioned earlier is across sectors, so it's actually covers the industrial and commercial sectors as well. So just a bit of background on household consumption in relation to the other sectors. Obviously, this just gives some indication of sort of volumes of consumption. Just by way of clarification, people thinking that industry sector is a bit big. It's all people on half-hourly meters, so it isn't just industry, it's also some commercial users as well, so that's why that looks bigger than it would normally look in relation to the services sector. But I think the point we're just making about this is the actual volume, overall volume, tells you one thing, but it doesn't necessarily tell you anything about how that relates to system costs in terms of the time of day that it's used at. And that's the point I want to next. Clearly, different sectors of the economy have different load profile characteristics. And on the more peaky than others. And I think if you look at a series of profiles of where demand is during the day, if you look at industry, you see that that is relatively flat across the day and indeed across the seasons. It does vary a lot by sectors, but there's been a bit of a dearth of really up-to-date data on the industrial sector, so to understand exactly how this splits down from sector to sector within industry, there is not a lot of up-to-date data on that. In the commercial sector, you see a morning rise, but thereafter it's fairly flat throughout the day. Again, the profile varies by type of activity, but there is not a huge amount of real data. Ofgem commissioned some work last year by Untitled on this, where they confirmed that there was not a lot of up-to-date real data on the commercial sector, so to understand how and where it's used. Households, very different. Morning and evening peaks. And so households make a significant contribution to the total evening peak. So on that previous slide, you see households contributing to average electricity demand. Average electricity consumption is about 30%, but to the peak, the evening peak, it's about 50%. So households are actually making a much more significant contribution to demand at those peaks. And that just is a representation from some modelling work that was done for the Sustainability First project like Rattle, just giving an indication of where household demand spreads out during the day, both in the weekdays and at weekends. And we see this significant increase, particularly in the evening peak period. So, we've got quite a lot of policies around to deal with energy demand, particularly for demand reduction. We've got the new Green Deal and the Eco, which are getting going now, and obviously we'll have to see how those develop and get taken up. We've also got quite a lot of policies on renewable electricity and heat, and Australia's got very similar schemes for these sorts of things, particularly on feed-in tariffs. It hasn't got an awful lot on the energy demand side. It's got some schemes in particular states, but not necessarily throughout the country. But there's a lot of discussion in both countries about the scope to reduce costs in the electricity system, and quite a lot of work's been going on in DECC. What do we do on the electricity system? What do we do about costs in the future? But I think there is sometimes a bit of a tendency to develop more on the peak side in one track, and work on the overall demand side in the other track. And this, I think, lack of joining up is already raising some issues in Australia, but I think could be potentially a big issue here in the future, particularly if we start to electrify heat and transport on the scale that is potentially being envisaged. So just being clear on what we're talking about, the two terms sort of used on demand response and demand reduction. Demand response is about changes in electricity use, shifting use from particular times of day, so shifting from peak to off-peak. So demand response doesn't necessarily reduce the total amount of electricity that's actually consumed, although it often does lead to some reduction, because there are some things that if people don't consume at peak, they're not going to consume it later on. I mean, if you turn off some of your lights at peak, you can't sort of get it back later on. But obviously, if you choose not to cook a meal at peak and cook it later, then you do still use that electricity later on. So some of it leads to an overall reduction, some of it leads to a shift. Demand reduction is very much about an actual reduction in the amount that's used, so not just shifting. And demand reduction has been more, I think, mostly been promoted for either carbon savings, obviously that's a really big area, or policies that have been addressing things like food poverty, or trying to encourage savings for customers. So that's been very much the focus of demand So why do we do this within the electricity system? And just saying, I'm really focusing here on costs in the electricity system. So there's lots of reasons why you might want to do demand reduction in particular, and a big reason you might want to do that is for carbon. Really what I'm talking about here is what will reduce costs in the electricity system. And one potential of demand reduction and demand response is on the wholesale side. So if you use less at peak or overall, you might be able to reduce your short or long run wholesale costs, either the short run costs of fuel or operating costs of power stations, long run billing of power stations. You might do something to improve system reliability through demand reduction and demand response, or you might do something to reduce network reinforcement costs. So if you don't have to meet so many peaks, then in the future you might be able to build and reinforce the networks. So ideally, all these things work together. We can achieve we can reduce carbon, we can tackle fuel poverty, and we can reduce costs in the system all at the same time. It isn't always as simple as that. And so we may find that the things that are best from one perspective may not be the best from the other perspective. So if we think about the electricity system, the costs in the system and what it does to bills is very much driven by peak demand as well as overall demand. So overall demand is important, obviously the total amount of electricity is important, but peak demand is a particularly important driver of costs, particularly if you've got some infrastructure that's effectively not used for most of the time, but companies have built it, power generators, the network companies, they've got some costs they've got to recover, and so that then means there's cost in the system that they've got to get back from somewhere. So thinking about peak demand is important, because if we reduce overall demand, but if peak demand stays the same or increases, we can increase cost in the system. And the worst case scenario of that is that people can be doing all they can to reduce their overall demand, but actually the cost in the system is still going up. Coming from somewhere. So tackling peak as well as overall is important. And that means that if you think about it from an electricity system perspective, demand reduction isn't all equal. So at the moment, if you or I reduce our electricity demand, it doesn't matter what time of day we do it. It doesn't matter if we do it at night time. It doesn't matter if we do it in the afternoon or in the early evening. It will save us the same amount of money on our bills because we're on flat tariffs by and large. But there's a big difference between, in terms of what will benefit the system, in terms of doing something like reducing lighting use between 5 to 7 p.m. in the winter, or improving the efficiency of electric hot water heating that's heated overnight, for example. So that will have the same value. So, for example, if you better insulate. So in terms of the system, those things got different values. However, I think it's fair to say that in GB at present, there isn't such a huge difference in values. So this is because we haven't got such a big peak problem in the UK at the moment. So the fact that there aren't the tariffs around, probably isn't such an urgent issue at this absolute present time, because the difference in value is not so great. But that difference in value is likely to increase as we go forward. So peak demand, already a big issue in Australia, and I'll just say a bit more about why that is at the moment, but not so much in GB at present. But one thing that will make, obviously, the difference between peaks and non-peaks important will be if we have a lot more intermittent warming in the system. So we'll have times of day when we have plenty of generation producing, and times of day when we won't. And that won't necessarily be the same as the sort of peaks we've got at the moment, so this is not necessarily going to change. And then we've got potential increases in electricity demand at peak times, particularly from electric vehicles. You think about the way people unconstrained might choose to charge up their electric vehicles. They probably plug them in the evening and they get them work exactly at the peak time. Heat pumps will run throughout the day, so clearly they will be taking electricity irrespective of time of day, and obviously some of that will be at peak. So the need for the value of demand reduction and demand response is likely to increase in the future in the electricity system. And so it probably makes sense there for us to start to get ready for that period and start thinking about what we need to do about that. So just say now a bit about Australia. Really big peak issue in Australia. So about 25% of retail electricity costs derive from peak events that occur less than 40 hours a year. And that growth of peak demand relative to overall demand has been a major factor in costs in the system in Australia. And particularly driving the cost has been the cost of building networks to meet peak demand, to service peak demand. So you can see here that whilst the peak demand went up 1.8% a year between 2005 and 2011, total electricity demand grew about 5%. The maximum summer demand in some states is particularly high. Because of the growth of that. So you can see that rise in peak demand. What's causing it? You can probably guess: air conditioning. And air conditioning in the household sector particularly, because I think whereas offices have had air conditioning for quite a long time, the household sector has taken up air conditioning in large numbers in quite recent years. So 10 years ago, they're just putting a number that there has been in terms of in recent years. And so you see here you've got from 59% in 2005 to 73% of air conditioning in 2011. Now in some states like South Australia, that's probably getting close to 90% of households with air conditioning. So it's significantly high, significantly driving peak demand. Obviously that peak demand time is in the early evening, late afternoon, early evening, when you've still got the business demand, but you've got the household demand coming on as well. That's been quite something. Now, it's eased off a little bit in the last couple of years because Australia's had a couple of, up until this last summer, which I've been fortunate to experience, which is very hot, but the previous two summers have been quite a bit cooler, and so that peak problem hadn't been quite so significant, but it has gone back up again this year, although not quite as much as before. What's being done about it? Well, the Ofgem equivalent, the Australian Energy Markets Commission, produced a piece of work last year, which I think if anyone's really interested in this, I would recommend. It's called Power of Choice. And there's a lot of stuff on the AEMC website. There's their own reports and a lot of commissioned reports from consultants that they got done, some very interesting ones. And they've recommended that there should be a move towards time-varying network charges to incentivise time use pricing. Network charges are a very significant proportion of the bill in Australia, about 50%. That's a lot more than here, it's about 20% here. So network charges are a big proportion. So clearly, if you get network charges based on time varying prices, then you would expect that that would then pass through to retail prices, that would incentivise the retailers to do that, and that's the thinking behind this proposal. How quickly that actually gets implemented is a whole other story about the complications of the political system, the federal system in Australia, and the extent to which individual states choose to implement that policy, which is a recommendation from the ERC. The other thing, however, is the growth and uptake of solar PV, which has been massive in Australia in the last few years. And similar questions about feed-in tariffs raised here, and similar significant drop in the amount of feed-in tariffs that are actually paid now. So in some states are virtually getting rid of feed-in tariffs altogether, but other states have cut them right back because they're done at state level. But despite that, I think solar PV is still increasing in uptake because the price of the panels has come down quite dramatically, and it's now almost cost effective to do even without feed-in tariffs. And that is starting to have some impact in the daytime because people are starting to use, some people are starting to think about using their own electricity in the daytime rather than network electricity. So that is starting to have some effect on the peak, and there is some work going on to try and work out how much will have a peak demand in the afternoon. However, what is, I think, the big concern, and is in the sense the lesson to learn, I suppose, from this, is that because so much investment has been made in the networks in recent years to meet this forecast peak demand growth, reductions in demand may not actually reduce costs, at least not for a long time, because there's so much investment there that's to be recovered. So the networks will have a legitimate expectation of recovering that investment for a number of years. So it could be quite a number of years down the track before benefits of reducing demand people overall will actually start to feed through. So, could electric heat do the same, give us the same problem here? Heat pumps clearly are one way that we're looking at potentially decarbonising heat. Now, I think if we put heat pumps in properties that were electrically heated at the moment, and particularly where people are on peak electric heating, give some figures on that at the moment, not such a problem. But clearly, if you put a heat pump in a property that's previously been using other fuels, you are significantly adding some electricity demand, and obviously part of that would be at the peak. Heat pumps have to operate most of the time, producing low heat levels, so they will need to run throughout the peak. And some interesting work was done by Red Point Elman at DECC last year. Looked at the model demand response there for heat pumps. Now they found you could reduce some demand in the 5 to 8 p.m. peak, but you increase demand in the afternoon peak where you've got industrial commercial load on stream. So you get value, you probably wouldn't get as much value by shifting some of the demand backwards. So clearly what we potentially need with heat pumps is storage. This is one way which could actually make a difference. If you can store some heat and release it later, so you can take it in at a non-peak time, use it later, that is one way to potentially manage that. However, at the moment, a lot of these storage units are quite large. The low carbon network fund project in Power in the North East has been trialling some storage units with their heat pumps, but they're very large, they're very heavy, and they're very expensive, and that means there's some limitations on households who are willing to accept them, have somewhere to put them. So we're going to need to do something about the size of that storage. And that raises the question of whether the old forms of electric storage heating, which have been around for a long time, you get a new generation of those, slimline, not taking up too much space, or maybe something else that people might want to be thinking about. The other important point, I think, for heat pumps is obviously you need the buildings well insulated to avoid excessive demand, and you've got this issue here, particularly in solid wall properties. So you must avoid putting heat pumps into properties that aren't really well insulated. Electric vehicles, potentially similar issues if people start charging those when they get home between 5 to 7 p.m. And some of the distribution networks here are already starting to notice some impact of PVs in areas where electric vehicles where several people have them on the same street. So you get a cluster and have quite an impact on that substation. And clearly at present, most people who buy an electric vehicle wouldn't face a price incentive to avoid charging it up times even on flat tariffs, so there's no disincentive to charge it at that peak time. So I think what I was saying there is we need to also be aware of some unintended consequences of increasing peak demand, which can increase costs in the system. Because clearly if we do that, the networks will want to build to recover those, and everyone will basically have to pay for that. So we just need to think about how we manage that so we don't cause those sorts of problems. Clearly smart meters are going to facilitate demand side response, they'll facilitate time varying pricing, so they will enable us to have time of use tariffs or pricing or some form of load control tariff. I don't think we're going to see a huge amount of time of use until we've got smart meters widely rolled out, partly because I think it's complex to do it. You can't really do a lot on this until you've got a smart meter, and until you've got a critical mass of them, it's probably not worth offering the tariffs. And I think it will also be important that networks think about time varying charging, and that will then pass through to the retailers. And I think that is some area where, as I understand it, some of the common charging methodology group of the networks are starting to think about that. Because if you get those signals passing through to the retailers, then you might then start to get the time varying tariffs. And clearly, once you've got smart meters and you've got the ability to attribute time varying demand to different households, then you've got the ability to settle those households, and so you can have time varying wholesale charges which you can identify to particular customers. So I think post 2019 we potentially will see a lot of this, but I think we'll see probably a fairly soft approach on that in the meantime. The other question this all raising that came up in the discussion earlier in the day is about the extent to which everyone should be in the time of use tariff, or it should be voluntary. I think that's an interesting debate that we might want to think about, because if you have it on a voluntary basis, you think about who's going to pick it, and put the people who are causing peak demand. A few pointers on the policy side. Obviously the Green Deal and Eco are very much focusing on very much an impact on gas at the moment rather than electricity use. Obviously that's important because gas is a major source of energy use and a major source of emissions. But we have got about 500,000 households in Great Britain whose main heat source is on electricity. So this is people who are using electricity as a main source of heating, but they haven't got storage heaters, so they're going to be using direct acting heaters. So that would seem to be quite an important group to think about getting them onto some form of better form of heating, particularly if they're in off-gas areas, so they can't have gas anyway. Maybe there where you want to think about particularly focusing heat pumps or some new form of storage heaters. Because clearly it's less of a problem for a peak demand issue if you do this in properties that already use electricity for heating, because you've already got that demand of peak times, you're not planning a new demand. Again, I think I make a point about obviously you have to make sure you do effective insulation of these properties as well. But also I think it's quite likely that many of those people with peak electric heating are tend to be very into the property. There is just like a high proportion in the data I've seen of people in the lower income groups with electric heating and the higher income groups, so we might solve that issue as well. But I think insulation is something that's going to make sense for whatever we're doing. There's no reason why we should be doing as much insulation as we can. From a people at the moment, the electricity system perspective, this may have an impact on gas. But if we are going to have move to electric heating, then this is an area where I think we need to be getting properties ready for that future by boosting those levels of insulation. And I just think on the heat pump side, I mean, I think there's, as far as I can see at the moment, there is this requirement for loft and cavity wall insulation where feasible. But that, to me, suggests that you could be installing heat pumps in solid wall properties with poor thermal performance. And if that is the case, we want to look quite hard at that as to whether that actually makes an awful lot of sense. might be some scope in that and joining up these initiatives for the EU. Lighting, interestingly, there still seems to be quite a bit of potential based on the EST study that was done last year for DECC and DEFRA. I find it quite amazing that the penetration of CFLs was so low, given that there's about 300 million of things being given out under research. So I actually wonder where they all are, literally sitting in somebody's cupboards somewhere.
Charity shops.
Yeah, charity shops, but they're not installed quite clearly now. Maybe this is just a time lag, and sort of, this 40% of incandescent is going to disappear over the next few years as people fit with CFLs that are sitting in their cupboards. But you do wonder, and it does suggest that I think the EST were surprised that actually there was still so much potential on the lighting side. I'm not particularly looking at commercially, but if I was looking at commercially, you'd see in the commercial sector big potential lighting at the moment. There's still a lot of efficient lighting, and lighting demand is a very significant portion of demand in the commercial sector. And clearly that is in the evening peak in winter. So this may be an area where we want to think about should we be doing something more to try and get more efficient lighting installed in people's homes, or at least see whether is this problem just going to go away in the next 2 or 3 years as people fit these missing CFLs. The other thing I mentioned earlier was contentious question of whether people should be required, everyone should be on a time of use tariff. Well, we might not want to do that for everyone, but we might at least want to think about it, particularly with people with electric vehicles. Relatively simple technically to sort of put in a sort of direct load control option, an automated option, so that people, when they're doing this in local network trials in the northeast, so that the vehicle can be charged at some time over the night period, and those customers could get a lower price for that, get some incentive to sign up. My suspicion is that customers generally will only sign up to these sort of automation options, and there is a degree of resistance to them in terms of most of the trials that we've done. There's often customers who are not that keen on sort of automated options for various reasons. They don't like giving up control. We've seen the headlines recently about Big Brother controlling your fridge and all that sort of things. There is this concern that people have. You'd probably have to give them an override, so that they could charge it up if they wanted to early evening, but on that basis they pay a price for that, and that would be a way to try and get some control about that. So if we're not thinking about everyone going on some form of tariff, we might want to think about people being particularly with electric vehicles, and maybe if they're getting grants or loans or some form of incentive, that might be one way of tying that to it. Can we join it all up? Well, I don't think we can always join everything up because we've got lots of different objectives there. And there may be some very good reasons why we have to do things in different ways. But I think it's important at least to be aware of the impacts. I don't think it doesn't matter having different objectives. I think as long as you're aware of where you can be, you can't do it simultaneously. And you just think about those trade-offs and see that you can at least identify that there are some trade-offs, and then think about what we might do to avoid the risk of those unintended consequences. I'll leave it at that. I'm happy to take any questions.
Great, thanks, Jill.
Data, have you seen any difference in behaviours within the people that have that kind of tariff?
Well, there is some evidence that people with Economy 7 do, some of those people do try to use appliances overnight, so to maximise the value that they get from that tariff. So they run their washing machines or their dishwashers or dryers or so forth at night to take advantage of that. So, and obviously if you looked at, if you saw the slides here, but they're obviously on the Stakeholders website. You can see the low profiles for economy 7 customers as opposed to other customers, and they are very different. Just a big box higher use at night. They tend to slightly more use at the peak, and that's probably because it's really shifted to take advantage of night use. So, and certainly where tariffs have been trialled, the time use tariffs have been trialled, so they generally do lead to response. Customers do take advantage of that. So it does lead to
Yes.
I'm curious about your emphasis on electricity, changing to electricity. I mean, there have been so many things this present government